Hey folks, just wanted to record a quick screen recording here just to give you an idea of how things are going behind the scenes here with building out this Truss Analysis Toolbox, this 2D Truss Analysis Toolbox. So this is going to be, as you know, the first of many different toolboxes that are going to be available on the DegreeTutors website over on the Labs platform. So the first one is obviously 2D Truss Analysis. Once I have that completely built out, I expect that's where I'm going to solve a lot of the technical challenges and technical problems along the way, or hurdles along the way. Once they're solved for that 2D toolbox, I expect the development of the later toolboxes, the more advanced toolboxes, 3D modeling toolboxes, some final element stuff, to go a little bit more smoothly. Now, famous last words, it mightn't go smoothly, but that's the plan anyway. So I've been working away on this, as you know. If you're in the all access community over on DegreeTutors, you'll have an idea of what I've been working on. I've kind of been posting some screenshots and things over there for members to give you a sense of what's been going on. But now it's probably a good time to jump in and show you where we're up to with this. So as you see here on screen, this is the Labs, DegreeTutors Labs platform that you're familiar with. Now the bit I've been working on has been this guy, Structureworks. Structureworks is basically what I'm calling, it's the umbrella term I'm using really to capture all of the 3D, all of the solvers, all of the toolboxes that I'll ultimately be building into this platform. So let me see, in fact, before I dive into that, I'll just flag up while I'm here that I finished the text version of another course during the week. So if you go over to your filter here and look for courses that are video and text, you'll see that we now have the fundamentals of engineering structural dynamics. So we have the full dynamics workflow is fully text documented, and as you know, I'm sort of working my way through the back catalogue of courses producing the text lectures. So over here in Structureworks, you're kind of seeing the development version of things here. This is not how things look on the actual site. I've been working on this card here, which is basically going to be the next toolbox that I build out, which is our 3D frame analysis toolbox. They're all going to follow more or less the structure of the courses that I've built. So the next the next toolbox I want to build is the toolbox that goes with the space frame analysis course. Okay, but it's not ready yet, so we won't bother going in there. What I have been working on is this guy. This is our 2D Truss Analysis Toolbox. So again, this goes with our I guess the first in a series of courses that you'll have seen over on DegreeTutors. And in fact, if you click on the little button here, you can see that that's a link to the reference course. So if I just hit that, actually, that'll bring us over to the reference course for this lecture, which is this guy here, direct stiffness method. So the solver is built using what we learned in this particular course. Okay, so that's just a bit of an aside. So now that we've got that looked at, let's go into the actual toolbox. So this is it, right? So what are we trying to do here? We're trying to build a tool that allows you to take a structure, take the definition of a structure, the supports for that structure, in this case a 2D truss, and the loading that's applied to that truss. We want you to be able to put it into the website, essentially into the toolbox, hit a button, and then it does all the hard work for you and crunches the numbers, does the structural analysis, and gives you the numbers back. Essentially what we built in our Jupyter notebooks when we were taking that course, working through that course. Well, I just want to package that up for easy use on the website here. So this is what I'm working with at the minute. This is your data entry. And so this is the data entry is not as slick and as smooth as I'd like it at this stage. I've a few ideas on how I'm going to improve this, but for now you can either you can click into a box here and it'll give you some hints on, well, not hints, but some direction on how to enter the data. So this is our nodal coordinates, for example. I won't go through all of them in this detail, but what it's saying here is we want the format of our data is a node number, right? So node ID, an X coordinate, and a Y coordinate, right? And they go in this format. So it's basically comma separated values. So you can either type them in like this. So for example, let me see, what is that? That's 1 that was 106, and go to a new line and then type in your next node number, x coordinate, y coordinate. You can do that. It's a bit tedious. Or what you can do is paste straight in from an Excel file, and in fact that's what I'll do here. So if I just throw this over here for a second, collapse that down to give us more space. All right, here is the data relating to this guy. So this was one of the structures that we analyzed in that 2D truss analysis course. So I've essentially taken the data that defines that structure. So in other words, these are my nodes here. I've just put them over here in the Excel file. So we have nodes 1 to 8, the x coordinates and the y coordinates. Then I have the member definitions. So what have I got here? I have a member number. I have the node number for node I for that member, the node number for node j. I have a Young's modulus, and I have, what is that? That's the cross-sectional area for each of the members. It's all the same in this case. Then I have supports. I've had a bit of time to reflect since I wrote this course, and you know, the way supports or restraints are defined here, I think you can make an argument for it where we're basically putting in degrees of freedom here, numbers of degrees of freedom. I think for the purposes of a tool on the website, I want to make that a little bit more straightforward. And so what I'm doing here is I'm defining supports by stating the node number that the support relates to, and then whether it's restrained in the x direction, true or false, and how it's restrained in the y direction, again, true or false. So this is indicating true, true, so pin support at node 1, and not restrained in the x at node 5, and it is restrained in the y, so that's your typical roller support at node 5. That's going to be an easier way of defining those supports than you having to identify, well, you know, what is the degree of freedom number that's being restrained. And then as well, I'm taking the same tack with the applied forces. I'm saying instead of saying where within the force vector is that force applied, what I'm saying is just tell me the node number, tell me the x component of force, tell me the y component of force, and then I've written things in the background to crunch the numbers to produce or to transform that data into the required format. So essentially that data there is the data that would basically solve this particular problem. Okay, and so the easiest way to get that into our solver is basically just copy and paste it in, right? So let me jump back over here, and if I want to take my nodes, just literally copy and paste in, and let's do the same for our members. Let's dump those in there and do the same for supports. Now, I've spent quite a bit of time going through this. I've tried to build in a lot of error handling or error checking or user input validation. So little things like if you try and hit solve now, well, it's going to tell you, well, there was an error validating your data and you need to provide at least one nodal force, right? And so it's the same for them all. If I get rid of that, it'll give me, let me see, it should give me, well, it's telling me I need to deal with this error first. So if I deal with this error, which was the nodal forces, let's dump that in there. Let's try again. Okay, so now it's giving me an error here, and it's saying there is non-existent nodes. So essentially, it's looking at the elements here, right? It's saying, right, each of these elements is referring to a node number, but you've no node numbers. Okay, so there's a whole load of different error checking built in. Now I won't say I've built in the ability to check for every possible error that someone might make with their data input, but I've got most of the fairly obvious ones I could think of, at least. All right, let's just actually put the numbers in so the thing works for us. So imagine we've put all of our data in. We've got our nodal coordinates, element definitions, restraints, and forces. Now I should be able to hit solve, and the magic happens behind the scenes. We take this data, we send it away to a solver in the cloud essentially, and then it solves it, gives us our data back. So let's try it. Job submitted successfully, and here we have our data back. So what's happened is this data entry block, we're presuming we don't really need that anymore, so we're just collapsing that down, so we don't need to see that, and we've got our data back basically. Now, I'm going to say, first of all, this is not going to be very impressive looking, right? Because I haven't built in, it's one of the things I said in the post the other day, I haven't built in the data visualization yet. So there's no graphs to look at, there's no deformed shapes to look at, it's just the raw data coming back to us now. What I'm working on right now is building those visualizations, but it's not really in a state that I can really show it to you. So what we've got back, the problem is solved though. You know, we've solved the structure. I just need to make it look nice on the front end so you can see, you can visualize your data a bit easier. So what we've got is, first of all, an analysis report. So this is basically a report which I'll likely add elements to, but it's basically just giving me check marks to say the different stages of the analysis that were completed successfully. So we've got, you know, if you've taken the course, you know about all these different stages, because the whole idea of that course is that you know how to build something like this. So we've got our incoming data processing was okay. We calculated member lengths and orientations, built the stiffness matrix, solved for displacements, reactions, member forces. Then I do a few things. I'm likely to add to this as time goes by, but like one of the first things I checked to make sure that it was all okay was the difference between the applied horizontal forces and the horizontal reactions. Obviously it should be 0, and this is a number that's close enough to 0 for my liking. And we do the same thing in the vertical direction, and then I do so they need to be 0 or close to 0. Then I do something like I check the maximum deflection. So what I'm saying here is I'm looking at the maximum displacement of the node. So one node obviously has the maximum displacement, and I'm comparing that against the largest internodal distance within my structure, just to get a sense of how large the displacements are relative to the size of the structure in percentage terms here. And so you want that to be a very small number, right? I think I raise a warning here if it's above 1% or 10%. I can't quite remember. I'll have that more clearly laid out. So for example, let's say I change this force here on node 3. Let's just say 1, 2, 3, add 4 zeros to the end of it, right? My deflection is supposed to be pretty big, and sure enough, I'm getting a warning back. So it's saying, well, your maximum deflection is 34% of your maximum internodal distance. So I'm not saying it's wrong, I'm just saying, hey, that's a warning. You might want to take another look at that and make sure you're okay with that. So that's your analysis report. I'm likely to do more things or add more things to this. Like for example, I'll be building in the ability to do a stress check. I haven't got it as a data input or within the data input yet, but within my element definitions here, I'm likely to also add in the yield stress, or you'll have to specify the yield stress, and we'll check the stress when we solve the structure, and we'll check to make sure that the stress in each element is below the yield stress, because obviously if it's in excess of the yield stress, well then you're no longer linearly elastic behavior, and your analysis, technically your analysis won't be valid anymore. And so you're going to want to know pretty quickly, and I'll raise another warning down here in the analysis report, if any of the members in your structure exceeded their yield stress. So that'll be a flag for you to go back and check and make sure you're okay with that as the engineer. All right, that's the analysis report. Moving on down, well then it's just, well in fact let's go and put some proper numbers back into this. So let's go back to, I think that's what we had. Let's solve it again. And here we go. Okay, so what have we got? We've got our reactions, and of course, I mean, all I'm doing is solving this here. So we can go down to the bottom of this guy here, and we've got, this is the actual data that we should get, and we won't go through checking one by one, but you will see that we get the right data, right? So we've got our table of reactions. Now these tables I'm using have the exact same functionality as our lecture index table, so you can filter, you can search, I've enabled an option here where you can download the contents of this table into a CSV file if you need it, if you have a very large structure. We have all of the axial forces in our members, and of course you can do sensible things like arrange those from highest to lowest, for example. That might be something you want to do. And then we've got our nodal displacements. So currently that's all we have, right? We've basically just got data back, and I've just taken that data and I put it into tables. This gets much more interesting when, and in fact some of the things I'm working on now I think are a lot more interesting, right? Because like there's nice models, 3D models, not in this case because this is a 2D structure, but the functionality I'm building is for 3D models. So you'll see a 3D model of your structure. You'll see there's all sorts of cool things that we can implement and we can do in terms of visualizing the data, the stresses in the structure. the deflected shape, etc. It's likely to be a little bit more I mean, this is functional, right? I mean, this is fine. But what I'm likely to have in our solver is probably going to look a little bit better than this, I hope. Anyway, so that's it. So that's where we are with the solver, the 2D Truss solver at the minute. Like I say, you know, a lot of the back end infrastructure, a lot of the things that make this work are going to be the exact same for all of the different solvers. Okay, I'll swap out actual, you know, different solver code, but in terms of, like, you know, how all of this works as a website, as a software, essentially will be the same, right? So it's going to take a bit more time. I'm hoping to get this one complete and finished and available for members to use in January. That's the plan anyway. But I expect subsequent solvers to go a little bit quicker than that. And I've also got some really nice little ideas which I don't think I'm ready to throw out there just yet. But in terms of making this an easy to use workflow in terms of generating your models and then analyzing your models, right? And so I'll say no more, but let's just say it's going to be helpful when we start getting into 3D structures, right? And we start having to build more complex structures. You're not going to want to be doing this sort of, you know, typing out all of your numbers, right? You're going to want to model your structure, right? And get it into the solver, right? So you can kind of read between the lines and see where I'm going with that. Okay, so that's pretty much it. So you have a good idea. So it's coming together nicely. The 3D modeling side of things in the browser is an experience. It's taken a bit longer than I'd anticipated. Learning a lot. So I mean, I'm happy. It's great from that point of view. I love just learning about these new things and how to do them, so that's fine, but it's just taking a bit longer, so you got to bear with me on that. As I say, January should be when I get this out to members to use. In terms of what will be available to members to use and the general public, well, everything is obviously available to all access members. I'm not quite sure in terms of limitations that will be placed on this for Joe Public to use. I have to have a little bit more of a think about that. But again, that's a conversation for another day. So I'd say we've said enough now. Let's leave it there, and I'll keep working on this in the background. I'll plug away at it over the Christmas break and hopefully make some headway. And it's Christmas, right? So have a great Christmas, and I'll see you in January.